Hi guys, in this video we are going to study Sutherland-Hodgeman polygon clipping algorithm. It is the last part of clipping algorithm. So before we start our discussion, just I want to say you something. Whenever you watch such videos, always keep a copy and a pen with you and take notes whenever and wherever you think necessary. So let me start our discussion. So in general terms, what happens is Sutherland-Hodgeman polygon clipping algorithm is performed by processing the boundary of polygon against each window, corner or edge. Now, as of line clipping, if you have carefully studied the line clipping algorithms, then this polygon clipping algorithm is not going to be much difficult for you to understand. So in this case, the input is a polygon which you have to be clipped against the clipping window. That means you have to find out the visible portion through the clipping window. First of all entire polygon is clipped against one edge. Then resulting polygon is considered. Then the resulting polygon from the one edge is clipped against the second edge, and the process goes on like this. So how it goes? Say this gray area is the polygon which you need to clip, and this dotted rectangle is the clipping window. First of all, what you have to do? You have to clip the polygon against this left edge and grab the resulting polygon. If you clip this entire polygon with respect to the left edge only, then the resultant polygon will look something like this. Then this resulting polygon from the first step need to be clipped with respect to the right edge. So this is the polygon which we got by clipping it with respect to this right edge, and you have to do this entire procedure for other two edges also, that is with respect to the top edge and with respect to the bottom edge. In this picture you can see the clipped rectangle with respect to the top edge, and this is the bottom clipped rectangle. Also, this is the clipped rectangle where clipping has been done with respect to all the four edges. So this is the final output. So some procedures you need to follow while you will clip a polygon with respect to some edge. And before delving into the procedures, just look at some of the situations which might arise in polygon clipping. Just look into this diagram. This dotted square is your clipping window, and this polygon with the solid line is the polygon to be clipped. Can you figure out what will be the resulting polygon? Just give it a thought. Okay, if you look carefully, you will find that after clipping you are going to get more than one polygon in this case, or more than one disjoint polygons. after clipping, this is going to be a polygon. This one is going to be another polygon which has been clipped, and this one is the third polygon. I hope you have got my point. So here you can see the polygons you will get after clipping. Here, from a single polygon you get a disjoint set of polygons after clipping. Now look into another situation. What will happen in this case? These are the clipped line portions, right? Once you do the clipping, or once you apply the line clipping algorithms to each and every edge of the polygon to be clipped, these are the clipped lines. So after clipping the lines, you need to join this clipped portions to get the resultant polygon. So here is your original polygon before clipping. Now during clipping, these are the line segments you will get. So to generate the resultant polygon, you need to join these segments. So why I am saying all this? The reason behind this discussion is that you need to develop a generalized procedure by which this clipping can be accomplished. And here are the set of rules. Say P1, P2 is an edge of the polygon which you need to clip, and this is again your clipping window, which is made with the dotted lines. Now you need to follow a certain direction. Say we will look from P1 to P2, or in other terms, the direction of this line is from P1 to P2. Now the generalized rules go like this. If point P1 is outside and point P2 is inside of the clipping window, then your resultant vertex set will contain the output intersection, which in this case is P1 dash. That is the intersection point between the line and the clipping window edge. This you need to store in your output vertex set, which will define the resulting polygon, as well as you need to include the point inside the clipping window into your resulting vertex set. So this condition you need to follow when one end of the line of the polygon edge is outside your clipping window and another point is inside. Now go to the next condition. Here you can see that both the endpoints are inside the clipping window. So in this case, you need to include only the second point of the line into your previously created vertex set, if this is your direction. Have you got my point? If not, just give it a thought. Pause the video here, think it carefully for a while, then come back. Now go to the third case. In this case, what happens? If this is your direction, then the first point of the edge or starting point of the edge is inside the polygon, and the second point or end point of the edge is outside of the clipping window. So in this case, what you have to follow is, into your existing vertex case, you need to include only the intersection point, which in this case is P2 dash. This is your intersection point, right? Then come to the fourth case. In this case, what will happen if the edge in concern is totally outside the clipping window? You can see that the edge P1, P2 of a polygon is totally outside the clipping window, and here you don't have to include anything into your vertex set. So you can see that we actually covered all the 4 possible cases. If this is your polygon which you need to clip, and this is your clipping window, and if you assign some direction to all the edges of the polygon to be clipped, then an edge can either go into the clipping window from outside to inside, or it might be totally inside the clipping window, or it might go from inside the clipping window towards the outside of the clipping window, or in fourth case it might be totally outside the clipping window. And if you follow our previous discussions, then all the 4 possible cases have been covered. And if you follow this 4 conditions properly, then this is going to be your clipped polygon, right? So what is the takeaway? The takeaway is, first you need to define the polygon which you need to clip in terms of vertices. Then you need to follow this 4 conditions, and depending upon the condition you need to create a vertex set with respect to a certain edge. Say in this example we have generated our vertex set with respect to the left edge. Now you get a new polygon in terms of this vertex set after performing the clipping operation with respect to the left edge. Now on this resulting polygon you need to apply the same 4 conditions with respect to all the 3 remaining edges, and you have to generate the vertex sets one by one. Say after generating the vertex set for left edge, the next vertex set we will generate with respect to the right edge. So VR next is going to be the polygon for input purpose towards top and bottom edge. If you go on like this, the last vertex set which you will get is the final output or clipped polygon. So hope you have been able to understand all the 4 conditions and how you need to apply them. Next, let me do this with an example. In this case, what happens? Uh, P1, P2, P3, P4 is the polygon which you need to clip with respect to this dotted clipping window. And for the time being, let us assume that our direction is from P1 to P2, then from P2 to P3, then from P3 to P4, then from P4 to P1 again. And just for the ease of use, let we put all the four conditions in front of our eye. Just put it here. Somewhere here. Right. Then, now let us start with the left edge. That means this edge. This is our left edge, and we start from P1 towards P2, then from P2 to P3, then from P3 to P4, then lastly from P4 to P1. So if you look into the line P1 and P2, and your direction is from P1 to P2, and this is your vertex set. Now among these four conditions, just look for a while which condition is being satisfied. If you look carefully, you can find that this third condition is the condition which you need to follow. Here what happens? P1 is inside and P2 is outside. That means you need to include the intersection point. So just think carefully. What is the intersection point among this line P1 and P2 and this left edge? To find the intersection point, you need to extend this line a little. If you extend the line, then you get the intersection point, which let me term as P2 dash. So now you need to include this P2 dash into your new polygon definition. Next, now you look into the line P2 to P3 and say this is our direction. Look into these four conditions. Now which condition you need to follow? Just give it a thought. I hope you have been able to figure it out. The condition is the fourth one. If P1 is outside and P2 is outside of the clipping window, then what happens? Do nothing. You need to ignore this line. You don't need to include anything into the new polygon definition. Then go to the third line, that is the line from point P3 to point P4. You have to follow the same directional convention. Now if you look into the four conditions, then this first condition gets satisfied. Here P1, that means P3 is outside and P4 is inside. Then output will be the intersection point, that means this point, which say is P3 dash, and the endpoint, that is P4. Now you need to include these 2 points, P3 dash and P4, into the polygon definition, which will be generated after clipping with respect to this left edge. Let me include these 2 points, P3 dash, here is it, and P4. Now the last edge, which is P4 to P1. Again follow the same directional convention. Here starting point is P4 and end point is P1. So here this second condition will be satisfied. If P1, that means starting point, is inside, and P2, that is the end point, is also inside, then output is P2. That means into the output vertex set you need to include the end point, which in this case is P1. So let we include point P1 into our vertex set. So with respect to the left edge, everything is done and you have a new polygon, which is the clipped polygon with respect to this left edge of the clipping window. So how this new polygon actually look like? It actually looks like P1 to P2 dash, then P2 to P3 dash, P3 to P3 to P4, and P4 to P1. So this newly generated polygon, which is indicated by this blue line, blue solid line, you need to clip against the right edge. Now what will happen if you do this clipping with respect to the right edge? Just give it a thought. Let me start from P1 to P2 dash. So actually there are no intersection points with respect to the right edge, although point P1, that means starting point, is inside, and point P2 dash, the end point, is outside the clipping window. So there is no newly generated intersection point, so you need not to modify anything. Similarly, for the edge P2 dash to P3 dash, there we have no intersection points, so no change. Again, P3 dash to P4, no change, and P4 to P1, this condition gets satisfied. So you can see that the resulting polygon actually will be same as that of polygon VL. Now if you follow carefully, just do the calculation yourself. If you do the clipping with respect to the top edge, same condition as VR will hold and no changes will occur in the vertex set. Now come to the bottom edge. be bottom. Now let me do this with yellow line. If you look at the line P1 to P2 dash, now P1, that means starting point, is inside and the end point P2 dash is outside. So the output will be your intersection point, this one. Say this point is P2 double dash, and you need to include it into the vertex set, right? Then look into the edge from P2 dash to P3 dash. Again, with respect to the bottom edge, you get one intersection point, and that is basically here. Say this is P2 triple dash. So what will be the output? Output will be the intersection point and the end point. Intersection point is P2 triple dash and P3 dash. Now come to the third line, P3 dash to P4. Now if you look into this line, this inside condition, that is the second condition, gets satisfied. So output will be the end point, that is for this edge it is P4. So you need to include the end point P4 into your resulting vertex set. Last, P4 to P1. The starting point is P4 and the end point is P1. So just give it a thought, which point will get included into the resulting vertex set. It will be the end point, that is, in our example, it is P1. So what you need to do include point P1 into your resulting vertex set. Now you see, we have done the task of clipping with respect to all the four edges, and the last edge with respect to which we have done our clipping is the bottom edge, and this vertices actually defines the final clipped polygon. Now if you join this final vertices P2 double dash to P2 triple dash, then P2 triple dash to P3 dash, then P3 dash to P4, then P4 to P1, and P1 to P2 double dash, you can see that your polygon has been clipped. You have been able to find out the portion of the polygon which will be visible through this clipping window. So let me go back to our reading material, documents. Yes, here are the statements for the algorithm. Just have a look. Read coordinates of all vertices of the polygon as we did in our example. Read coordinates of the clipping window. That means by following steps 1 and 2, you are defining the original polygon and the clipping window. Then consider the left edge of the window. We started our clipping procedure with respect to the left edge. Then compare the vertices of each edge of the polygon individually with the clipping plane as we did in our example. Save the resulting intersections and vertices in the new list of vertices according to 4 possible relationships. These 4 possible relationships. So by doing this, actually you are getting intermediary clipped polygons. Now in step 6, it is being said that repeat steps 4 and 5 for remaining edges of the clipping window. That means right, top and bottom edges. Each time the resultant list of vertices is successively passed to process the next edge of the clipping window. Now once you have done the process for all the 4 edges of the clipping window, you are done. So stop. So this was all about Sutherland-Hodgeman polygon clipping algorithm. Just as I always say, first read this study material, then watch the video carefully, take notes wherever you think is necessary, then again read this study material carefully in between the lines. So have a nice day.